select.
Oh, hey, Honors Calc, how's everybody doing? So I just wanted to make this quick video just to wrap up basically the lesson from Monday and Tuesday. So this question is asking us to find all the values of x in this interval, which you could know is often like one period, we would say, of sine or cosine. Excuse me. If you're watching this, you may want to do double pace, as I often recommend. Well, if we want to find where the tangent line is horizontal, this is actually just where is the derivative of this y equals cosecant x. Where does that equal 0? Because that would tell us the slope. Well, the derivative of cosecant x, as you may remember from our chart up here above, is negative cosecant x times cotangent of x. Interesting. This is going to be a fun one to work out. So where does negative cosecant x times cotangent of x equal 0? Well, this is actually, because that'll tell us where it's horizontal, where it has a slope of 0. Well, this we could actually use the zero product property, because if cosecant or negative cosecant of x, we actually don't even need the negative there, because negative 0 is still 0. Where is cosecant of x equal 0? And where does cotangent of x equal 0? Because at both of those values, it would satisfy this equation and make the slope 0. So let's think about it. Cosecant is 1 over sine of x. Well, actually, there's nothing that sine could be to make that 0. So actually, we're not going to get any solutions from the cosecant part. But cotangent, if we think about that one, let me put some commas here to separate. That's cosine of x over sine of x. And since we know they have sort of this symbiotic relationship, well, this is going to equal 0 just where cosine is 0. Because when cosine is 0, sine is 1. And where is cos of x 0? If I think back to my unit circle, it would be cosine is the x value, right? So it would be at the top and the bottom if we're just talking about that interval on 0 to 2 pi. So this would be, well, this is pi, right? This is pi over 2. This is 3 pi over 2. And then a full rotation would be 2 pi over 0. Just talking about. So it looks as though it would be at these two x values if we're talking radians. X would be pi over 2 and 3 pi over 2. And I've already prepared the graph down here below, and if we look here, this is this funky graph where we've got cosecant of x up here. This is the cosecant of x, that inverse one. Here's the sine of x one. So it's got a horizontal right here at x equals pi over 2. And it's got a horizontal right here at 3 pi over 2. To clarify, we're looking at the graph of the original function, which way up here is cosecant of x. So we can then see that cosecant of x, bam, 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 which is the inverse of the it's the reciprocal, I should say, of y equals sine of x. You can see, bam, bam, that's the only two spots from 0 to 2 pi where it has a horizontal tangent line, where it flattens out. So that was not too bad. Now that we are combining, we're adding our trigonometrics in here. Much love, everybody. Hope you have a good day off, and I'll see you all on Friday if we do Thursday asynchronous.